Hello and welcome to another night shift. My name is Yazil, and today we want to move our characters with animation and bringing them over the network. Therefore, I opened two clients. As you can see, we got two characters in there, and if we go here, this character turns. We know that already. But if the character moves with the F key, starts moving, and it starts moving also in the other window. Also can go back there, and he's moving also. So we are going to use root motion for everything, which gives us a little trouble in what happens if we move the character when he or she is not moving with root motion. So maybe we push her a little. So you see, even then in both windows, the character is moving on the right position. You can see that if we start there direct, we are on the right side. So for that we need a couple animations. Let me close that so my PC is not slowed down. For that I used raw mocap data. You can of course use any animation you got somewhere. If we go to the asset store, it's just raw mocap data for Mechanim. It's from Unity and it's totally free. So let's look on these asset for a sec. We got the animation, which is raw data, so we have to go in there a little bit, and we got a default character and we got the materials for the character. So if we go for an let's say an idle animation, and we take this neutral, and we go on the preview. Normally you should have the preview down here. You can undock it so you can see it any better. If we start there, you see the characters start moving and idle a little bit. So that we can work with that, you see the animation is from 50 to 3200 something, with different animations in it. So we don't need the whole clip. What you have to do is, let's stop that. What you have to do is find with these a position where, let's say we have this one, and we're going to see the end of the clip and going for finding a point where it's 0 also, or green. That means the start position and the end position looks like the same, and if we go there, well, we could go there all the way and see that then. Let's find a smaller one. These, for example. And you see the animation is running through, and he's at the same position when the animation is over. Since we want to have it loops, we're going for loop time and loop pose. And if we're going to see now, you don't see any edges on that. If you do, you just go and see if you get 1 frame or 2 frames more or something like that. You have to find something which is fitting. The next point is the root transform rotation. We don't want to move in the rotation, and we also don't want to move in the position. And This part, root transform position, we at the idle point it makes no difference because we want to stand at the point. But if we use root motion, that's the part where the animation goes for area in one point of a direction. Let's say we go backwards, we're going back minus on the z-axis, and if we go forward, we go positive on the z-axis. You still see there is a little velocity on this. If you want to get that down, you have to see the value is here. Oh no, that's the wrong one. The value is here. No, it's what was the right one. We see that better on the run animation. Well, that's basically what you do for getting your data out of the mocap. We will revert that. Here on the rig, you get the humanoid and the model. You should have that on default. That's perfectly fine for the beginners. And well, as the animation, there could be some warnings. For example, the import message, it says here that the hip and the transform is not correct. You can bake that into there, so it doesn't has to calculate it all the time if you use the animation. Well, I show you my neutral I use. It's neutral 2. There it is. As you can see, I used from 463 to 783. Loop time and loop pose are fixed. The cycle offset is 0, and we bake the transform, and we bake the position, the rotation, the position, and also I root the position. Because we don't want our character to move while in idle. And if you did everything right, you see here the average velocity is 000, and the y speed is 0 also. I baked the arrows here, and so if we play that, let's see what's gonna happen. Nothing. He's looking left and right, and when he's done, he's back to the beginning. So that's my idle state, and then we go to the walking state, and we got here in the walking forward, and we're gonna click that, and here you can see the difference between the normal and the root motion stuff. It's red here in this position because we want to have the player on a different position than he was before the animation started. So if we go there, you see the character is moving slowly forward, and for that I used the whole animation here from 0 to 90. You also can go from 92 to 59, I would say, which is basically the same, but you see there's a little drift on the side, so we have to fix that. If you move it a little bit to there, so it's 0.8, and you see the velocity for the x-axis is 0, so our character moves straight the y-axis. And Well, you really don't want to bake this position because of the root animation, and it says we have a velocity here from 1.5 into the y-axis. So let's save that, apply, and then I have a backwards walk, and it's here. Let's start that. You see the character is moving backward, and I used from 85 to 114. Loop time and loop pose are backed also, and the root transformation rotation is also backed, and we made sure that the values are 0, 0. And the root transform the y, we bake that, and of course we don't bake the motion. So after that, we don't need anything more in a moment, but just a little hint: if you have something like strafe backward and forward, you see here the values are the same, because if you have found a left one, you can use it as a right one, but you have to click on mirror here. And so that the thing is working, you also have to cycle offset. So we want to basically start in a half of the animation to be the start of the right strafe walk. So if we go there, you can see it works in that direction. If we go for left, it works for that location. So that's only if you're interested in that. It's really not too hard to get this stuff out of the raw mocaps. Next we think, or we need an animator. Just close that up. So you just, I had an animator, and I used the male animator. So just right click, create, and an animation controller, name it to, in my case, male animator. We hit that. Let's get that a little bit bigger. In the animation, it's really not so hard. You just get, and let's see, we go to our animation, go on our idle state, which is idle ready or idle neutral. You pick that up and just drop that there, and you see you got something like that. If you want to have this as a starting point, you just right click it and say, let's set a layer default state. So if we do that, we switch to there. No, we don't want to here, want it here. Next, you do that with walk forward and walk backward. And these are transitions. You just click on the walk forward, right shift, and make a transition here, and you set it where you want to have it. And in this transition, we have a value, and the value is speed. I show you that. It's under parameters, and you set make a new value. So star plus, hit plus there, and make a new float. Call it whatever you want, and that's the condition we want to have in this transition. So if the value speed is greater than 0.2, go into our walk forward animation, and for that to work direct, you have to click here on has exit time is normally so, and you uncheck that. So direct, if you hit the value, you don't wait for the idle animation is to stop. it just moves to the walk forward. And on the next transition, on this one, you just say if the speed is lesser than .3 or .2. I got .2 here, .2. Okay, we're gonna make that .2 also. And the same is for the walk backward. You just move the animation in here and make 2 transitions. And again, it's right shift, make transition, go to the field you want to make, like so, and then set the conditions. And in this case, it's when speed is lesser than minus .02, go into walk backwards, and if the speed is greater than minus 0.2, go back into the idle state. So you see, I got a jog forward here also. Let me show you the values for that. It's under running. It's under running, or it's under sprinting. Let's jog forward, this one. Jog forward, neutral, face forward. So my values for that is 53 to 74. And we got a loop time, of course, and loop pose. And there's still a little. Let's see if we can get that away. 9, 8, 7, 7. So we changed it to minus 3.67, and you see the average velocity to the x-axis is 0 now. And apply that. We can go for preview and see how that looks. There is he running, so looks good. Okay, oops. So animation, there we are. And the condition between this pose is if the speed is greater than 1.1, go into jog forward, and if it's lesser, .1.1, go back into the walk. So that's all for the animator in the moment, and I show you a little about this different, the other I made already. It has a locomotion with an 2D, so you can change between this. That comes somewhere in the future, I don't know yet. We just use these mail animator, and for that to use, we go into our scripts. No, at first let's go to our start location and go for our player, and go here in the player scripts and set the mail animation. So get the animator or the controller and put them down here. Okay, and then let's go to the player controller, and the player controller. So we just don't need that stuff, so I get rid of that, and we just don't need that one. So in our player controller, we got that already. We changed that to adding the animator to it, and it's the I called it my anim, and we added a run speed. The run speed is at the beginning at 1, so we need to run to false, and we need this in the start function. My player is get component player, and my anim is get component animator. And we just make sure that the root motion is set, so we just apply root motion is true. And in the update function, we check the input key down and the key code .numlock. And if we press the numlock we want to run is equal to not run. So if it's true, it's false. If it's false, it gets true. So if it's true, then we set the run speed to 2, else the run speed is equals to 1. So next is myPlayer.speed. We set that for equals to run speed multiplied with the input axis vertical. This value speed, we need that to transfer over the network so we can get the other players synchron. So just make a value for now and set it to public float speed in the player C# script. So back to the player controller. And next we're going to set our animation with the function setFloat, and the setFloat looks for a variable with the name of speed. If you remember right, let's go back there again. We have a parameter which called speed, and we set that speed to the run speed multiplied with the input.get axis vertical. And the next you know already, I think you have it in there, it's transform.rotate, and the new vector 3, and we get our horizontal input there and add a little factor so it's not too slow. Well, that should be everything for getting our player animated. So if we go there and go into the login and start that, and going for to login, there's our character. Go for start player, click on our player, we see our player is in idle, and if we move he's going to change to the walk forward, and if we had numlock he's going to start running. So perfect. So next we prepare our network stuff. So for that we need to add in the y const an move subject. I called it anim. Later on we need stuff like state or fighting stand or stuff like that. So in a moment we just have anim here, and it's the 3, and we go into our player. In our player we set a new variable. The speed we already have, but we need to remember the old speed, so we have a public float old speed. It could be in private also. I just have it public for the inspector view. And next we go and see in our update function over here, we already have these and these. So we add, if the speed is not equal to the old speed, we send a message to our server and we tell them to send to others the move tag, the move subject anim, and the speed variable. And after that we say the old speed is equal to speed. And then we have to add in our position. So if we don't move, so our speed is 0, that our position is updated. You remember that part where I pushed the other player and the position was still updated. So if the speed is 0, we have to be sure our position is updated. So the rest is the same than we had before, but just add these uh, bit of code there. So that's it for the player. We don't have to do anything more. So save and go to our player others. And first of all, we have to set my position. That will be in coming fixes and cleanups. We also going for saved position of the player, but for now, you just have to have the same position than we have in player. So if you look at player, we got in my position a new vector, and that's the same starting point. And to make that starting point come true, you go to your make UMA. Yes, make UMA. And here on this position, you say transform.position is equal to my position. So he starts at the same position and we know where he is. And then we go for our receive data. And we have that already, that we checking is the sender ID is equal to the network IDs. Only then it's interesting for us because that's free. And we have a new subject here. If it's the move subject anim, and if we do that, we set the speed is equal to float data. So we got a variable here on top. It's called public float speed, same as we have in the player, and we just set that speed value. And now you might tell me, oh, well, nothing has changed. Of course, nothing changes because here in our player ready callback, where we set the expression and the capture collider, we add a new game object, which is the others anim controller. That is the script we're just going to make. And that's here. It's really easy. It just depends on player, as our player controller also. We going for mono behavior, and we have a public player others. It's my player, and got an animation, an animator. It's my anim, and we got a float run speed, which we don't need, which is from recopy. So we delete that. In the public void start, we just look for my player and get the component player others. Since we add these other anim controller to our player others object, we just can get the component. And we're going for my anim and get the component animator. And for the security reason, we set the root motion is equal to 2. And then in the update function, we just go and go for our myanim.setFloat, and we're looking for a variable speed, and we set that with the myPlayerSpeed. That's the variable we get here from the network. Where is it? A little bit down, we had that. Somewhere down there. Oh no, not in manager, it's in player others. Player others here at this point, we set the speed to float of data. So the object gets out the float, and we read that out there and set it to the variable. And in our other anim controller, we check for this variable, and if it's changed something, we're gonna send that to our animator. So that's it. That's all. So as you can see, as I built it a new version, it just works, and there is our character. So my player was built on a different position, but my player others, sorry, but over the network it is synchronized, of course. And so that's all in the moment for part 5. We got the player running, we got the player moving in the network, and the next stuff we want to do is to optimize the code and add a couple things on the one or the other edge. For example, the player position. For example, what happens if the player is quitting, so saving position and stuff like that. Also, we want to work more on the humor face and body, arm lengths and height and belly and stuff like that. Also, what I noticed that we have a little trouble from the one or the other watcher. So I want to make another TTT for what to do when we got in the troubles. For example, I can't get any data or stuff like that. So I want to explain a couple errors. That's the plan for the next few weeks. And after that, we start with an user IE and get our item system on the start. Yeah, well, that's it for now. I hope you had fun and happy night shift. See you.